Alright, taping from the back office, so the lighting's probably not the best, but we'll get it across. To write an equation in vertex form, you're going to write it in a times x minus h squared plus k form. To write something in standard form, that's the ax squared plus bx plus c. Write the equation in vertex form. The first thing I had to do is find h, which is to find the opposite of b over 2a. So I want my final answer. I know a is always the same. If there's nothing there, that means 1. X minus something squared, and I'm going to fill in the blanks. Opposite of b over 2a, negative 8, over 2 times 1, which is 2. You get, of course, negative 4. Of course, when I put a negative 4 in here, it becomes a plus sign. Okay. Plug negative 4 in, I get negative 4 squared, plus 8 times negative 4, minus 5, 16, negative 32 minus 5, negative 16 minus 5 is negative 21. And that's that. Okay. Now to write it in standard form, this squared means x minus 2 times x minus 2. And then it's just a matter of doing order of operations from there. Foil this out. Could you distribute the negative 3 first? Absolutely, but I think if you foil it, you find it easier. X squared, you get negative 2, and negative 2 makes negative 4x plus 4. Then distribute your 3 plus 12x. And then simplify and write it out as such. Okay. You can always check your answer by trying to rewrite it in the other form given the steps. Works for me. Down here we just started simplifying. Remember, negative 12, that goes 4, 3, and negative 1. So really I get negative 4 plus the square root of 4, which is 2, the square root of negative 1, which is I, and the square root of 3, which I can't do. There you go. This is not a FOIL problem. This is a minus this entire term, and the minus sign will distribute into both of these like a negative 1. So really what I'm doing here is just combining like terms. And again, negative times negative, negative times negative gives me positives here. Okay. Oh, forgot to put my I there. Combine like terms. 14. There you go. That's it. 27. This is a FOIL problem. First, outside, inside, outside, or last, excuse me. And that's 12i squared. Now, remember that I squared equals negative 1, and when I times it by negative 12, it becomes a plus 12 out here. And when I combine like terms, I get 52 and negative 17i, and there it is. On to factoring. When I factor, remember I get the brackets like this, so I'm just going to go through and start doing that. Now, they're not all like this, but they are here. X and X, the factors of 24 that add up to get 2. 1 and 24, 2 and 12, 3 and 8, 4 and 6. There it is, 4 and 6, as long as I have plus 4 and minus 6. This problem is 2x and x because the factors of 2 are 2 and 1. Oh, and on this side I get 1 and 12, 2 and 6, 3 and 4. And really it's a guess and check game. Because I don't want to waste your time, I'm going to tell you the answer is 3 and 4. Because what happens here is, here I get 6x, here I get 4x, I need a positive 2, so the 6 has to be positive and the 4 has to be negative to give me that 2x in the middle. Okay, so negative 4x would have to go there, and plus goes there. And there's my answer. There is another answer here. If you pulled out a 2 from every term first, it's a lot easier. I would get 2 times x plus 3 and x minus 2. Both answers are correct. I would take either one. This is difference of squares, simply x plus 9, x minus 9. This is also difference of squares. Keep in mind, the order of the exam is very similar to this. So you're going to get a few of these. The answer is not set it equal to 0, it's just factor it. Down here on 32, you get x times x squared minus 36. Factor a GCF out first. In fact, you can see GCF is going to show up on this problem and this problem, where here I can factor out not a 2 really, but I got an x squared I can at least pull out of every term. Come back to this one. X, that's difference of squares, plus 6 minus 6. The answer is not x equals plus or minus 6. I'm just factoring. X squared, I got 2x and x because 2 is a prime number. And I'm going to go back to the factors of 12, which I actually wrote right up here. So rather than trying to guess and check here, I'm going to tell you I'm going to get 4 and 3 because this would give me 8x and 3x. I need a positive 8 and a negative, so I need 2 times 4 to be negative, this positive, and I've done my work. This is a plus b, a cubed plus b cubed. This is a cubed minus b cubed. Sums and difference of cubes. That was section 6.2, I believe. You should know this by now, but a is this term cubed, x. B is this term cubed, 3, and it's x squared plus 3x, minus 3x plus 9. Okay. The way the formulas work, if you don't remember, is AB, make sure you can see this, A squared, AB, B squared, and then it was same, opposite, plus. That's the rule. Okay. So for this one, the cube root of 8x cubed is 2x. The cube root of 64, is 4. A squared is the entire 2x squared. And from that I get 4x squared. Multiply them together, 8x. 4 squared is 16. And again, whatever the sign is, it's same, opposite, plus. I should have done that this problem too. Same, opposite, plus. It's always that way. Alright, next problem. 36. Move it up here a little bit so I don't forget to do that. The zeros are just when you set each one of these terms equal to 0. This is already 0. This I would add 3 to both sides to get 3. This I would add 3 and then divide by 4 to get 3/4. Now, below here, find the zeros. I want even or odd. 3 is odd. 1, when there's nothing there, is odd. And 3/4 here is even because of that 2 on the exponent there is an even number. The total power determines, remember, where we start and where we end. And they always end up. I'll just tell you that. We're not going to give you a negative. So it's a matter of, does it start up or start down? And it depends on the total power. 3 plus 1 plus 2 is 6. If it's even, it starts up and ends up. If it's odd, it starts down and ends up as such. Okay? So I need to plot my zeros here. I got one at 0, one at 3, and one at 3/4. You're going to see a fraction on the exam. 3/4 is just a little less than 1, of course. Right there. It says total power 6. I'm going to start up. And at 0, I'm going to go through it. At 3/4, I'm going to bounce off it because it's even. And at 3, I'm going to go through it. Keep in mind, it says odd, odd, even, but that's not the order of these points. That's possible to do that on yours too. Go through it. Doesn't matter how low you go. You come up, and at 3/4, I bounce off it, come back down, and come through in the end. And there's my picture. It could be a little bit bigger loop down. Doesn't matter. It can be a smaller loop down as long as it goes through, bounces off, and goes through. That's what I'm looking for. I'm going to use these points, 0, 3/4, because I'm writing it in order, of course, numerically. And I'm going to determine from the graph where is a positive and negative. I don't know how far down or up it is. That's why I can't say what the max or min is, or for that matter where it's increasing or decreasing, because we don't know the exact point here. What we do know is that above the x-axis it's positive, so before the 0. And below the x-axis it's negative, after it's positive. Those positive intervals, so right here is negative infinity, and infinity is on that end. Okay? And I'm just going to write from negative infinity to 0, and my other one is from 3 to infinity. For the negative intervals, well, it's where it's negative, which is from 0 to 3/4, and from 3/4 to 3. And that's it for that page. Next page. Move back down here. I want to find my zeros, which are here, 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 and here. So at -4, -1, 2, and 4. I want to determine the multiplicity, which means even or odd. So -4 goes through it, it's odd. -1, it bounces off, so it's even. 2 goes through, so it's odd. 4 bounces off, so it's even. Nice how that works out. You can again see where it's positive and negative based from those points. It's below the x-axis before from negative infinity. above, above, below, below, towards infinity. So my positive again are where the plus signs are, between -4 and -1, and between -1 and 2. And then it's negative on the intervals from -infinity to -4, and from 2 to 4, and from 4 to infinity. Okay. Now we can determine local max and min here, and I'm trying to get these even on the exam to work out as nice points here. Right there, I should put a box maybe to make a difference, are our maximas, and there's actually one right there as well. Okay, so my maximas are at -1, 2.5. Negative, it looks like positive 0.5. Again, I'm going to make it fairly obvious. And then again at 4. The minimas will occur here. Let me see how I can maybe put a triangle on my minimas. Oops, not there. Here. Okay. So I've got two minimas. That's the bottom of hills. The bottom of hills, not there. That's a 0. X will then be -1, and it looks like 3. Okay. Now, from there, I can determine where is it increasing and decreasing. So I'm going to write them again numerically here. So I got -2.5, -1, 0.5, 3, at 4. And it's just a matter of reading your graph. Can you see where it's going up and where it's going down? It's going up from infinity. So I'm going to draw an up sign from -infinity. After that it's going down to -1. Then it's going up to 0.5. Then it's going down all the way to 3. Then it's going up to 4, and it's going down to infinity. Increasing are the 3 up arrows, of course. And decreasing, of course, are the down arrows, so -2.5. You shouldn't have anything that is the same, or you probably did something wrong. Okay, you got 3 of each in this case. That's the way it goes. I'm not promising that's the way it is on the exam, but that's the way it is on here. Alright, down below. Third degree polynomials in standard form with real coefficients and the following roots. So what I'm trying to say here is, first show the factors, and the factors are x minus a, and the a's are given. Next, multiply it out. So for here, it's x minus 0, which is x minus 2, and x plus 3, because it would be minus a -3. I think it's easier, you could distribute the x first if you want, but I think it's easier to just FOIL that out. X squared minus 2x plus 3x is plus 1x minus 6, and then just distribute the x, which gives me x cubed plus x squared minus 6x, and that's it. Now the thing is, if it involves an I or a square root, it also includes its opposite. So I gotta have that. If I had a problem that was -4 square root of 2, I would also have to have negative square root of 2. That's the way it would work. All i's and square roots come in pairs. This would give me x minus -3, which is x plus 3, x minus negative square root of 2, or excuse me, 2i, sorry. I'm going to rewrite this whole thing. X plus 3, x plus 2i, and an x minus 2i. And yes, you can FOIL these out, but it is always easier if you can find things that are opposites, and that plus 2xi and minus 2xi are going to cancel. So x plus 3, x squared, again, plus 2xi and minus 2xi would cancel. I get minus 4i squared. We talked about it already. I squared is -1 times -4 makes it positive. So really what I'm doing here is going and FOILing that out now. X cubed plus 3x squared plus 4x plus 12. And that one's done. Okay, let's move on to the bottom here. Synthetic division, hopefully you remember this drops real easy here. I always put the factor, and the factors, remember this is x minus a, so a here is 1, a here is -5. Now I'm going to plug 1 in first, bring the coefficients down, and I get that. First thing you do is drop it low, multiply, add, multiply, add, multiply, add, multiply, add, and what you want is 0. If you don't get 0, you did it wrong. Try it again, okay? But you got to get it. When I tell you they're factors, that means it goes in. Now don't start over again, because this will give you an x cubed plus 4x squared minus 17x minus 60, which I still can't factor. I can't even group it up. So what I want to do is just immediately go to the next term, because then it'll get me down to an x cubed term. Of course, we always drop it low. That's always the first step. Multiply, add, multiply, add, multiply, add. Again, I got 0 because it worked. And what's left is x squared minus x minus 12, which can be factored. X and x. Factors of 12 are 2 and 6, 3 and 4. Yep, 3, 4, minus 4, plus 3. And that's it. That's actually my answer. I guess if you just were to circle that on your exam, I'd be content. I'd give you the points. Moving along. One more page for this. Alright, so synthetic division to find all the roots. Okay, well, a lot of this comes down to, I'm not going to give you a first term. I'm just not. I don't want to make it harder than what it is. But you got to find all the factors of 24. Think a minute. What are all the factors of 24? Had to take a drink of water. They are 1, 2, 3, 4, 6, 8, 12, 24. And what's worse is it's plus or minus for all of them. Now my number on the exam is not going to be quite this difficult or quite this many options, but you got to keep trying. And what I've said in the past is the way I would try if I were you. Oh, you couldn't see any of that, could you? Yeah, you could. Sorry. Is I would try 1, -1, 2, -2, 3, -2, and so on. Okay. So with that being said, let me try 1. And I think this is the way that you should do it, and that most of you will do it, is try it in this order until you see one that works. 6, I'm doing it kind of fast here. I know that's not going to give me 0, so I'll go on to -1. Good time to maybe realize that you should use a pencil on the exam. That's not going to give me 0. Let me try 2. And, you know, it might take you a few tries. I'm probably not going to give you it so easy. 2 goes in. Let me see. I got 7, 14, 12. Ah, there it is. There's my 0 that I want. Leave me with x squared plus 7x plus 12, which again can factor into x and x. I've got plus 3 plus 4 are the factors of 12 that add to get 7. And what it wants here though is all the roots of the zeros. So not just the factors. I even wrote it right in the definition, in the directions, excuse me. So what I do is I set each of these equal to 0. The first thing is the one that worked, which is 2. And the other ones, I have to set them equal to 0. So they are the opposites. Okay? Now, done with chapter 6. That's all the stuff from chapter 6. I'm not going to put a quadratic formula problem on here. We're going to go on to the trig section, and the trig section talks about coterminal angles and reference angles. Coterminal add to 360. So really, to find them, you can just take 360 minus the given, and you'll get your other one. 360 minus 32, borrow, is, and you'll get a calculator for this whole test, so please don't try and do that in your head anyway, because I'd hate for you to make a silly mistake on that unless you just know you're really good at this stuff. And I get 328. It is positive because the one given to you is negative. In other words, really what I'm doing is asking what is the length of that, and that would be 328. Okay, and I'm going counterclockwise, so it would be positive. This is clockwise, so I know I'm going to have a negative here. I'm going to come back to B. And again, 360 minus the given is 149. Okay? So negative 149 degrees for my second angle. Now reference angle is positive less than 90 degrees back to closest x-axis. Really, it's the same thing we would do for these, and y'all know how to do these. We always connect back to the x, never to the y. So from here back to the x-axis is 32 degrees, because this 32-degree angle counterclockwise, so it's the same the other direction. This one though is right here, and that may be easy or may not be easy. If you think of the whole distance from here to here, that's 180. How much more do I have to go to get to 211? Well, 211 minus 180 is 31, and that is the answer. The other way you can do this is, you know, this is 149, so if the whole thing is 180, how much more do you have to do to get to 180? 180 minus 149 is another way to get 31. It does not matter which way you do it, they're both right. Draw an angle in a reference triangle. I am going to give you the reference triangles, the 1, 2 square root of 3 and the 1, 1 square root of 2 triangles. I'm going to give you those for the exam. Okay. Sine of negative 135 means I go clockwise. Second quadrant, because this is 90 degrees. Anything that ends in a 5 is always, always, always a 45. 45, 90 degrees. The fact that it's sine, we'll get to that in a second, but again, anything that ends in 5 ends there. Remember, we always connect to the x, never to the y. I'm going to label here as such, and anytime you go left or down, it's always negative. Okay. The sine of negative 135 is the opposite over the hypotenuse, negative 1 over the square root of 2. I can simplify the square root of 2. I can never have that in the denominator, and I get negative square root of 2 over 2, and that is the solution. I just want to find the sine of the angle that's always attached to the origin. Same thing here, tangent of 300, I'm going to go counterclockwise 90, 180, 270, so 300 is somewhere down here. Always connect to the x, which forms my 90-degree angle. If this is 270, this much more is 30, so inside has to be 60 because they always add up to 90 degrees in every box. Everybody knows that. This is 30, across from 30 is 1, across from 60 is square root of 3, and the hypotenuse is always 2. Hypotenuse is never, ever, ever negative, but negative square root of 3 is because it's down. 1 was positive because it was right. Tangent is opposite over adjacent, so negative square root of 3 over 1 is the negative square root of 3, and I do want you to reduce it from there to there. For the last problem on this page, and for the last problem on day 2's packet, is, and your one end of your exam is going to look just like this. I know we had one where you had to find both of them and use the arc sine or arc tangent or something like that. You're not going to need to use arc on the exam. What you are going to need to know is that all triangles add up to 180 degrees. So what I got here is 180 minus 90, that's given, that's 90, minus 54, which comes out to be, well, borrow, and I get 36. This is 36 degrees up here. Okay. Now, from there, my children just entered the room, so you're going to have to bear with me if they make a noise. Okay, and then what I'm going to do here is label from the one that's given, what are the sides? This is the side opposite, this is the side adjacent, and this is the hypotenuse. Now, what do I need here? I got to think about SOHCAHTOA. What is what? And you know what? It's probably not a bad thing for me to write it out again because it's probably been a while since you've thought about SOHCAHTOA, my boy. And what am I going to do here? I'm going to use opposite over hypotenuse. I got to use the hypotenuse because that's given. So I'm going to be using sine and cosine here to find some values. Let me just label this x and this y. For the side opposite, I'm going to use opposite hypotenuse. I'm going to use sine of 54 equals the opposite over the hypotenuse. And when the letter's up high, you multiply. X equals 18 times sine of 54. Okay? Now, I'm not done yet. Multiply that out in your calculator, and I will just tell you that you're going to get 14.6. Okay? Always multiply 8 times sine of 54, not sine of 54 times 18, because it'll just multiply the wrong thing. Okay? For the other side, for y, I'm going to use adjacent over hypotenuse, which is cosine. So cosine of 54 equals the adjacent over the hypotenuse, which is 18. And then the letters up high, you multiply. If it was the other way around, remember, if you had to divide, that the trig function is always in the denominator, but that is not the case here. And I will get 10.6. That is it for this page. That is it for day 2. And on the last page, we will do on Friday in class, and I might make one short video for that as well. Have a good day. Say goodbye.
Can I wave my hand?
Say goodbye.
See ya.